All right, hello everyone. Today we're going to look at what the least squares regression line actually means in terms of the variables and the sum of squares. So what I've got here is just a bit of data. So I've got age and then some height. So I just put that in, I've labeled my columns, and I've also created a scatter plot with age as my explanatory and height as my response variable. So we're going to chuck in a regression line and we're going to look at the residuals and the sum of squares. So usually to put in a regression line, we go menu, analyze, and then down to regression. What I'm going to do for demonstrative purposes though, we're going to actually use a movable line and we're going to move that around and see how that affects our residuals. So for the movable line, if I chuck that in, we get a nice straight line. So the CAS has already tried to fit a straight line to our data. It's as best as could. We've got an equation up. What we're also going to do is we're going to see the residuals. So under menu, down to analyze, number 7 for residuals. We're going to go our residual squares, and I'll explain what that means in a second. So when I go show residual squares, it's going to come up with all these squares. So what these squares are, I've got our data point, we've got our straight line. So if I go straight down from our data point to our line, that's going to be the predicted value using essentially our regression equation. So that distance there, that's our residual. And what the CAS has done is taken that distance, it's moved it across there, and it's made a nice little square because they're both the same distances. And the sum of squares is just the sum of all of these areas. So all of these 6 boxes, all these 6 squares, find the area, add them together, and I've got 16. So what our least squares regression line does is that it'll minimize these residuals, and in turn it'll minimize the sum of the squares. The reason we turn them into squares is we want to deal with positive values because these are all above our predicted value. So they're all going to be positive, our residuals, but these residuals are going to be negative. So if I try to add them together, naturally these negatives will cancel out the positives. So by turning them into squares and area, they're all positive values. So I'm just trying to get that sum of squares as close to 0 as I can. So if I just move this line around, what you can see is if I just move it up a little bit, we're already up at 80. If I move it down, we're at 112. Before we started at 16, so see how close I can get, down to 15.5, 14. So about 14.6-ish. If I kind of change the angle a little bit, we can get it even lower. Got it down to about 11.2. Maybe if I move this one, so we're getting it even better, down to about 3. I reckon 3 is as low as we can go. But yeah, so you can see as I move this line around, each of those squares gets a little bit smaller, and overall the sum of squares gets smaller. So we're down at 3. I'm going to keep that up there. What we're going to do now is we're going to draw in the least squares regression line that the CAS calculates for us. So menu, analyze, then we're going to go down to regression this time. So from regression, we're going to go show linear a plus bx. So that's the one we want to use, a plus bx. So as I hit enter on that, that comes up with that line. So now that's my equation, 68 plus blah, blah, blah. If I go again to show residuals, so my residuals, show residual squares. So again, before we got it down to about 3.0-ish. Our CAS calculated one gets it down to 2.9. So that's as low as it can go. So that is my least squares regression line, where it's minimized the sum of the squares as much as it can, and it can't do any more. So that's saying that's the best line it can possibly fit. So that's what it means when we do our least squares regression line. So thanks for tuning in, and I'll see you all next time.